Good afternoon, ladies and gentlemen. Good afternoon, ladies and gentlemen. Welcome back. I hope you had a great lunch. So welcome to the Caribbean Actuarial Association's 2021 virtual conference with attendees and disruptors from across the world joining us to continue embracing the disruption. My name is Nikita Gibson. I am the chair of the conference this year, as well as the moderator of this session entitled Data Science and Banking. Allow me to introduce the speakers today, Mr. Trevor Wood and Mr. Nigel Henry. Trevor is the Director, Data, Wealth, and Corporate Center Technology at CIBC FirstCaribbean International Bank, where he has enjoyed a 20-year career. He is responsible for developing and executing the company's data strategy and overseeing the delivery of strategic solutions across a diverse project portfolio. Trevor is a former valedictorian of the University of the West Indies Cayfield campus, where he graduated with a double major in computer science. He also holds a master's in banking and finance with distinction from UWI, as well as numerous technical certifications. Trevor has done extensive work with charities, non-governmental organizations, and the University of the West Indies to promote computer science education, in particular, due to his belief that business opportunities of the future will lie primarily in the digital frontier. He has collaborated with region-wide Girls in ICT initiatives, whose aim is to encourage girls to pursue careers in ICT, is a trustee of NOAA, No to Online Harassment, and collaborates closely with the University of the West Indies in support of their Nerd Days and the national science fairs they host. Trevor is an aspiring writer and is passionate about promoting local culture, creativity, and creatives. Now, Mr. Nigel Henry joined CIBC FirstCaribbean as a data scientist in 2019. In this role, he's responsible for converting the bank's vast amounts of financial and customer data into actionable insights. Before FCIB, Nigel was founder and principal consultant of Solution by Simulation, a consulting firm that applies analytics in retail, public opinion, the nonprofit sector, and social science research. His professional career in data science first took off when he was recruited by Obama for America for the role of head of analytics for the targeted states of Virginia, North Carolina, and Florida, all of which went red to blue in 2008. He holds degrees from Yale University and the George Washington University. This session is expected to last 60 minutes, and here are a few quick housekeeping items. Feel free to drop your questions in the Q&A box to be answered at the end of the presentation. All sessions, with the exception of the professionalism workshop and the AGM, will be recorded and uploaded to the CAA website and ActiveView. By registering for this conference and attending this session, registrants hereby give permission to the CAA to use any text, photograph, or video taken during this virtual event. Now, this will not be a Caribbean conference without entertainment, so check out the pub quiz tonight and don't forget to submit your videos for the talent show tomorrow night to win prizes. And also, don't forget to follow us at Caribbean Actuarial Association on LinkedIn, Facebook, and Instagram. Finally, thank you to all our sponsors and conference partners, and particularly for this session, we thank CIBC FirstCaribbean International Bank for being the session sponsor. Without them, this year's conference would not have been possible. So remember to visit their virtual booths by clicking sponsors in Zoom events. Thank you, and now I'll turn over to our speakers.
Thanks for that introduction. Thank you for the opportunity to present at this conference. Let's just get straight in, data science and banking. So as you would have heard in the introduction, I am a data scientist. What does a data scientist do? First of all, I ask an interesting question, get the data that's going to answer that question, explore that data to see what's going on. Then we create models, different kinds of statistical or machine learning models that we'll talk about, and then communicate and visualize the results. So what methods do I use? What techniques or skill set do I bring? Well, it reminds me of question that a reporter once asked me when I first moved back to Trinidad, and the newspapers asked me, wanted to do a story about what was this whole data science thing. And the person said, should I call you a statistician? And I said, well, I'm not quite a statistician. And then after talking, the person said, oh, so you can do everything a statistician can do and more. So I had to correct her and say, okay, well, I can't do everything a statistician could do, but I do use statistical inference to do my job. So what do I use? So statistical inference, as I said, we need domain knowledge, which is knowledge about the actual domain or the topic to which we're applying data science. We need a programming ability, and then also what this guy Drew Conway calls hacking skills. So that's the ability to take unstructured data like natural language data and so on, and put it into a structured format for which we could use the models. So we have to bring all these things together, and that's what makes the perfect data scientist, right in the middle of this complicated Venn diagram. So if data science is so powerful and so important, how come you've never heard of it, or how come it wasn't an option when you went to school? Well, because data science is very new. Although the algorithms that we use existed before, and even some of the applications that we want to use it in existed before the 2000s, what we didn't have two important things. We didn't have the space, the storage capacity to store pretty much unlimited amounts of data, and we didn't have the computing power to do the kinds of to run these kinds of algorithms that we wanted to do in big data. But slowly but surely, over the last 2 decades, we have then been able to use big data in different kinds of ways. And slowly but surely, we started to narrow down on what exactly are the skills that a data scientist needs and what do data scientists do. So I am very happy that I'm here, and I think it's very fitting because, in my mind, actuaries are some of the first data scientists, but obviously there's some differences. What do I do? It's a new profession, as I would have said. A lot of learning is informal, so online classes and so on, whereas you guys would be very well credentialed in doing exams and so on. We apply these techniques to various different domains: journalism, data journalism, economics, banking, as we're talking about today, political science, all kinds of different domains that we would use it in. So it's a little bit different in that way. We do make a lot of models, particularly predictive and prescriptive models, and those models will not only be things like regression, linear or logistic regression, as you may be familiar with, but also more advanced machine learning techniques like random forests and neural networks. So at this point, I'm going to hand over to Trevor, who's going to talk about how this applies to banking.
All right, thanks, Nigel. So why do banks need data science? So the Banking and the Financial Industry Act overall is a good area of focus to assess the impact of data science. And to kind of summarize where that is, I'll use a quote from Bill Gates where he said, we're always going to need banking, but we're not always going to need banks. And unfortunately, there is a whole industry that's seeking to prove that true, which would be our fintechs. And fintechs are ubiquitous, right? So banks are actually at risk of disintermediation by fintechs. And we're seeing it in the Caribbean. We have WePay, we have Bit, we have Actuarial, we have others. And there are other unicorns internationally, like Square and so forth. So what that means is that to stay relevant, banks have no choice but to compete on the digital frontier. And in order to do that and to be effective at digital, they need to be effective with their data capabilities, right? Including data science. And as a result, banking is one of the hottest areas of utilization of data science. So what you see right there on my left is a pretty primitive sphere. And I guess you'd be wondering what the relationship is between something as primitive as a spear and potentially one of the newest and most technologically advanced areas of endeavor that we're seeing across all industries. And this is my concept for the relationship between digital and data, right? So for me, digital is the tip of your spear, and it might give you contact, it will give you incision, that is how you permeate, that's your touch point with your clients. But the shaft of the spear is your data, and that's what gives you your power, and that's what gives you your precision. And if we were to ask you which was more important, it'd be very difficult to separate the two, right? So as a bank, or if you're out hunting and you're battling unicorns, you need a spear, right? You can't do it with just the tip, and you can't do it with just the shaft. So it's very important that the two complement each other well. And how do we know that they complement each other well? Well, we just look at the data. So there was a study done by the International Data Corporation, which aimed to correlate data-related challenges, but essentially to understand the relationship between data maturity and the effectiveness of digital transformation. What they found was that compared to low-level or immature data organizations, which they call data survivors, the data thrivers really benefited, prospered even, as a result of their digital transformation that was data-driven. So looking at some of the metrics there, what they found was that there was a 6-time operational efficiency improvement. Profitability was 3 times that of the data laggards. Top line revenue, customer satisfaction was double that. So at the end of the day, the point is banks need to remain relevant. They need digital transformation to do so, and they need data to power and direct that digital transformation. And data science is an integral part of that process. All right, so what helps to make data science successful? So there's no such thing as instant data science capability. You don't add a data scientist and stir, even if your data scientist is as good as Nigel is. Many data science projects fail. And in order to succeed, there are a variety of other things that need to be in place, So as Nigel said, the first thing you need to understand is the problem you're trying to solve. And it needs to be understood both by your analytics teams and your business teams. Secondly, you need to align your solution with the teams and the feedback from the teams to create the benefits that you're seeking. We say in the bank that analytics is a team sport. What that means is that you need to have other skills involved. And fourthly, along with the skills, there are other technical and governance best practices that allow you to, create and maintain the value that you need from your data science practice. And finally, communication, right? When you're working with data, when you're trying to predict something, you will invariably come across insights that require feedback, that may require you to change your direction. And you need to be able to communicate those effectively. So I'm going to go through the practices involved for covering all these things. So maybe by a show of hands, has anybody heard of design thinking? Okay, so quite a few. So design thinking is an innovation framework, and the way we employ design thinking is to get to the right question, right? As you see, there's research, you define, you ideate, but this is kind of the starting point. This is about getting to those questions that Nigel says, or as Nigel outlined, which is at the start of your entire process. So next, Agile. Is this familiar to anybody? Hands again. Okay, so Agile is known as a software development methodology, but in its purest form, it's meant to be about a mindset. As a matter of fact, Agile has its roots in car manufacturing, in Toyota with Lean, Six Sigma, Kanban, and that kind of stuff, and is actually quite aggressively used today in companies like Tesla, right? So it goes beyond simply software development. And what really captures the essence of Agile is the Agile Manifesto, which I've laid out here. And essentially it says, we value the interactions with individuals over processes. We value having something that works over comprehensive documentation. We value collaboration with the people who are impacted, and we value responding to change. So when we talk about being aligned, as we go through the process, as we build our models, being able to operate under Agile paradigm does a lot to keep us in step and to embrace change as we push the model through into production. Okay, so I know we spoke about analytics being a team sport, but there was one role in particular I wanted to mention, and that was that of the data engineer, right? So data scientists are highly sought after, and data engineers are just as highly sought after. The two are complementary, and I think the diagram there kind of depicts the relationship. Your data engineer is who creates the critical plumbing to deliver the right data to the right people and places at the right time. And your data engineering practice is really what is going to underpin the work that your data scientist does. So I've kind of encapsulated here to say that data engineers are data scientists' best friends. And we spoke also about the other technical components in being able to successfully deploy machine learning code. And when I look at this picture, it kind of says to me like it takes a village to raise a model, right? Similar to it taking a village to raise a child. And you have to parent your idea, and you have to parent your models. So what you see here, I won't go into everything, but there's, moving from being able to collect data, extract features, understanding people who can verify the data is correct. Then you have more technical aspects, right? Infrastructure, tools around analysis, process management tools. There's tooling to make sure that you are able to have changes done to your model in real time and to have the model serve up responses in real time. And then around all of that, there's monitoring, not only monitoring your infrastructure, but monitoring your code. So the point is, data science needs significant multidisciplinary support in order to be successful. And final critical success factor, analytics and visualization. So, we say that a picture is worth 1,000 words, but if it's worth 1,000 words, it has to be worth 1,000,000 numbers, right? And visualization is the skill, it's a critical skill that you need to be able to communicate and garner feedback effectively. And I think it's undervalued, but we find, especially, when you're in an agile process and you're getting feedback, and at the end of every sprint, every week or every 2 weeks, you're trying to demonstrate the progress you've made. Visualization and the analytics behind it become extremely important, right? So what I want to do now is go into a few of the ways that banks have used data science. So we've been talking about embracing the disruption, and these examples here are from Gartner, a study they did in 2021. So these are real life examples of banks doing their best to battle the unicorns, right? So some of the examples include connecting with clients. So what do banks want to do? They want to connect to their clients. They want to lend to more people. They want to be more efficient. They want to find and share insights with clients. And last but not least, they have a part to play in fighting financial crime. So let's walk through those different success stories. All right, connecting with more clients more frequently. And what you're going to see in these examples as well are the themes that Nigel spoke about in terms of the changes in the technology and big data. When we talk about the volume of data, the variety of data, and the velocity of data, and the requirement as a digital competitor to be able to do things in real time, right? Because real time is the speed of life on a digital frontier. So in this example, we see a bank that managed to use a large volume of data from a variety of sources to be able to execute marketing campaigns. And they actually went from being able to run 2 campaigns a year to running 13 directed, unique customer-specific campaigns a day. So let's look at, I guess, what a bank's raison d'etre would be, right? Lending, being able to assess credit risk, and being able to use more data and use it better has enabled this bank to use 15,000 data points, right? Including social networks, mobile usage, et cetera, as opposed to 300. And what has that resulted in? You determine credit worthiness in 35 seconds. You lend to 73% of people who don't have traditional credit scores. So these are people who may have been locked out of the financial system, right? And at a loss rate that is better than the traditional scores, with payments in 15 minutes versus a few days. So this is a tremendous success story. More efficient operations. And again, this is kind of a forecasting use case where the bank was able to forecast the use of cash across its ATMs, which resulted in better cash management. But I think the key metric there is that hours of customer wait time would have been eliminated. So being able to predict when people were going to take the cash out meant that they didn't go to the ATM at 2 p.m. in the afternoon and find that the ATM wasn't available. Right? This use case I thought was pretty interesting. So Nigel also spoke about natural language processing. And one of the things that we're seeing in data is one of the real big changes is what exactly is data? 20 years ago, it might have needed to be in a table and so forth. Now you have a case where people are able, where you have the technology, you can ingest unstructured data. And if you think about it, when you work with Siri, when you work with Alexa, what you hear, we're also able to translate into data. So what you're seeing now is that you have access to more data that can be codified and can be worked with. And in this example, what the bank was able to do was to communicate in natural language its insights, and that resulted in research available to subscribers an increase by 250%, as well as an increase in the quality and the consistency of the language of clients. And that takes us to our final use case, identifying terrorists. So there are different types of machine learning models. One is supervised learning, and I think Nigel will probably get into one of those where you have a target. But the other is unsupervised learning, where the machine detects patterns based on the data, right? And I found this use case particularly interesting because using data science, the bank was able to establish a relationship between the likelihood of someone being a terrorist and their inclination to purchase life insurance. And as a matter of fact, it seemed as though the bank was able to help authorities identify some terrorists based on what they were able to do with the data. So I hope I gave you a decent overview of what it takes to make data science successful and what the banks are doing to help to embrace disruption, so to speak. And now I'll hand you over to Nigel for what is the most exciting part of our presentation.
Thanks, Trevor. All right, so let's look under the hood. Let's be a data scientist for the next 10-15 minutes and see data science in action. So what we're going to do is we're going to look at a competition or a challenge, let's say, that was hosted on Kaggle, but hosted by the Actuaries Institute of Australia. And I decided to, use something in your domain. So it's new to me as well. But what this actually does is the challenge is to use demographic data, a description of an accident, natural language, right? Somebody just types in a description of an accident and employment details and predict based on, those types of data, what the eventual claim would be for that accident. So data science is, it's a science. And generally what we do in data science space is we start with a hypothesis, right? So we've asked an interesting question. The question is, how could we predict the eventual insurance claim from an accident? And we can start with a hypothesis. So as the experts, how about you can type in the chat, what types of things that you would want to know in order to predict beforehand, ahead of time. what the eventual claim would be. And Trevor, maybe you can just shout out some of the answers if we do have some folks that are brave enough to suggest some features or some attributes. So let me just talk. Sorry, go ahead, Trevor.
Gender, and it's important that a lady is who said that.
Right. Okay. So maybe gender might have something to do with it. Any other suggestions? No? All right. Well, let's see. Oh,
Age.
Absolutely. I would imagine so.
Any others? One more. Job.
Right. Well, yeah. Profession. Exactly. Right. Yeah. So let's look at this. And so what we're actually going to do is we're actually going to. Sorry. Go ahead, Trevor.
And there was one other one. The area for driving. So I guess where you drive.
Okay. Okay.
So
makes sense.
Like a Bermuda Triangle of sorts.
Fair enough. Okay, so what we're actually going to do is we're going to actually walk through a notebook, a Jupyter notebook, which is code for, I think, what is the 5th place submission. So this one would have correctly identified the fifth closest in terms of root mean square error, right? So difference from actual. So let's go through. So as I mentioned, first we ask an interesting question, which we did. The second thing, if you remember, is to get the data. So let's look at the data that we have. So this is written, this notebook is written in a statistical language called R. It's okay if you don't understand R. I'm going to walk through it with us and kind of show you, how we can get to the answer. So we would load some R packages. And what we then do is we look at the data that we have. So Kaggle, or the Australian Actuarial Institute, on Kaggle provided a training set. So this is a set of actual real examples of accidents and the eventual claims, and a test set which you had to try to predict, right? So the training set, it looks like, has 54,000 observations. And there are 15 variables that were presented: the claim number, date and time of accident, the date the accident was reported, age, which I guess some of you think is going to be very important, gender, right, male, female, or unknown, marital status, that may or may not be important. Let's see, the number of dependents, both children and non-children, the weekly wages of the claimant, whether they're full-time or part-time, the hours they work per week, days work per week, and then a natural language description of the claim. All right, very interesting. So let's see how we could throw that into a model, into our prediction. The initial claims cost, and then finally the ultimate incurred claims cost. So this is the target. This is the thing that we're trying to predict. And as we can see, it's often not, and I guess you guys will know more than me, it's often not the same, right? So the initial estimate in this case was 1,500, but the correct answer was 4,748. Again, the initial was 5,500, the correct answer being 6,326, right? So it's not a linear straight relationship between the initial and the final. And the question is, can we use any of these other 13 variables to help us predict what this ultimate incurred cost could be? So we have 54,000 in the training set, and 36,000, again, real actual examples of claims to try to predict. So, right, so that's the second thing, get the data. The third thing, if you remember, is to explore the data, and that's what we're going to do right now. We're going to explore the predictors, right, which in machine language terms we call them features, and we're going to explain the dependent variable, we call it the target in machine language terms. So in the target, what we're trying to predict is as you know, the ultimate claim. It looks like there's a range between 122 and this looks like about 4 million, probably Australian dollars, with a median of 3,300, right? So it's a very skewed kind of distribution, which is very difficult to predict something that's this nonlinear. So what we sometimes do, all right, so we can see here the box plot, so there are many outliers. So what we sometimes do is that we would create logs. So the author of this notebook took a log to the base 10, and we see something a little bit more normally distributed, a little bit easier to make a prediction here, right? So we see some of them in the hundreds, some in the tens, some in the hundreds, some in the thousands. It looks like they're a good bit in the thousands, and some going over into the millions, right? And then you see the box plot. So it's a lot easier then to predict. It looks like most 75% of claims are between 10 to the power 3 and 10 to the power 4, right? So again, easier to predict. So that's the target. What we then do now is we do something called feature engineering. Feature engineering is taking the raw features and creating new features. You could think of them as like calculated fields. So let's look at some examples. So they would have taken the time of the accident, date time, and split that up into the year of the accident, the month of the accident, maybe accidents in December, maybe higher or maybe lower than in the middle of the year, who knows? The same thing for the report. And then also let's look at this. This is an interesting one. The lag is calculated. So the difference between the date time of the accident and the date reported. Maybe we might find that accidents that are reported right away are different from the ones that have a lag in terms of the eventual claim. So let's do another round. So of the raw features, we saw that there were. I'm going to put them back up. I'm going to scroll back up. Of the raw features that we have here, and maybe some of the calculated ones that we did, which ones do we think are probably going to be most important? And Trevor, maybe I could could ask you to just shout them out again. So do we think that age and gender are probably going to be the more important ones, or are there some that
we have a claim description,
right?
Gender keeps coming up, age is back.
Right. Got it.
So
okay,
reporting
cool.
Like that's
all right, let's see. Let's see
ages, gender, age. Okay,
I would imagine. All right, let's see what actually happens. All right, so here we go. So let's jump straight in. So we have some more engineered fields. So how do we actually get a claim description into a machine learning model, right? So one of the things that we do, the author of this notebook created these dummy variables, if you will, by using individual keywords, right? So strain, back eye, and so on. So it looks like it would be 1 in that column if the word strain is used, and 0 if not, right? So we create all of these dummy variables here. And this is a description of our data, right? So age, it looks like there's a range between 13 and 81 with a central tendency in the low 30s. So we see these raw features and some of the categorical features as well. So for example, strain is mentioned 15,000 out of the 45,000. I is less well mentioned. It's only mentioned 4,500 out of the 45,000, or 54,000, sorry. So we see those as well. Let's just look at feature distributions. So remember, the third step is to explore the data, right? So we see this age is skewed. So there's a lot of people in their, I guess it looks like late 20s or mid 20s to early 30s. It seems to be where the central tendency is. Most people have 0 dependence. And the reason that the data scientist is doing this is to get an intuition about the data. You need to know what's under there, right? And then the second thing that we're going to do, so we see accident hour, right? So most accidents, it seems like, happens around midday and less so in the middle of the night, right? Makes sense. And the next thing that we're going to do is look at the relationship between, between the features themselves. So for example, we may do a correlation matrix. So like maybe some of the features, let me get that, might be very highly correlated with each other, right? That might make a difference in the model. But then again, also part of the exploration, we're looking at the relationship. What is the qualitative or even the quantitative relationship between the features and the prediction itself? So just to take a couple age, which I guess a lot of people think is going to be important. As we can see here, you guys may be able to see it. I think I could see it as well. People who are younger tend to have lower claims, and then that seems to level out with age. Let's see if we see anything else interesting. Somebody said weekly wages, right? So we see a pretty high correlation, so a correlation of 0.32. That might seem low, but I mean, when you compare it to a lot of other things, 0.05, 0.04. In the real world, in real messy data, this 0.32 is actually pretty strong. This is a pretty strong relationship. And we could see as weekly wages increase, the eventual claims are also going to increase. So we take all those features and we mash it in together. There's just one other thing I'm going to show in the feature engineering step, which is that it looks like the author of this notebook used a package called H2O Word2Vec. And what that does is it's a kind of a semantic clustering. So it takes all of the descriptions and it removes stop words and so on, words that have no meaning. But it's going to put each one of these descriptions into one of 10 groups, depending on how similar the words appear to each other, right? So it's gonna put those together. Then is the third step, creating the model, right? So again, the author of this notebook created, it looks like 4 models. XGBoost, which is a very powerful machine learning model, is one of them that I'm going to go through. I'm not going to go through the others in as much detail, but basically, this is where you actually build the model in this short block. So you tune the hyperparameters and then actually fit the model here. And right now, it's like, as Trevor said, the machine learning code, the ML code, is just a very small part of it. Just in this one line, it's going to fit the training set to the target using this XGBoost model, using root mean square as the objective function or the thing that we're trying to minimize. All right, so there we see over the various iterations, the root mean square goes down. It looks like it starts off about 30,000 and then it levels off to about 2,300. So if you could think about the range is anywhere from, I think 211 was the lowest and 4 million was the highest. I guess maybe getting within 23,000 on average got this person to be in the top 10 in this particular challenge or global challenge on Kaggle. Right, so yeah, so that's it. So what we could then, now we built that model. It looks like it took these 600 rounds with the final model. It only took about 38 seconds to build that machine learning model. What we could then do is explore the model. So one of the things as data scientists we like to do is look at feature importance or variable importance. What are the things that make the most difference? So obviously, as I would expect, the initial claim has a lot of signal. It's a very high predictor. The question is to me, the better question is, how do we account for the difference between that initial claim and the eventual claim? What makes a difference? So we see weekly wages, as you predicted, makes a big difference. We see the description. I think that was the last one that came in. The description, the semantic clustering, makes a big difference. The year, so I guess maybe that means that the claims increase over time. Certain keywords like laceration or eye seem to make a difference. Some of the other ones that we would expect, like I guess being male, ended up not making too much of a difference once the other factors are taken into consideration. So being male is down there. Being gender unknown is down here as well, one of the lowest. So that ended up in this particular model not being one of the most important. So there are thousands, literally thousands of machine learning models. So this, again, the author would have trained XGBoost. They would have also trained GBM, gradient boosting machines, which has its own model. And then we could see that it has its own things that it thinks it's important. So for example, the GBM thinks if it sees back is a lot more important. And we didn't see that in the other model. So they would have trained 4 models in all. And let's look at some insights. What we then do is we could look at all the models together. So here we see the prediction and then the actual. So no model is perfect, but we see in general the prediction tends to be in line with the actual, and we could see that some of the models do well in certain places than other models. And so what we sometimes do is that we combine all the models together, and that's what this data scientist would have done. I guess here he's looking at the correlation between the models, so they're very highly correlated, but not exactly correlated. But by combining the models, we would then get an even more accurate prediction. So that's kind of it. All right. So after doing all of that, they would have submitted the blended model, or what we call an ensemble model, to the competition. Right. So I think that's it. Hopefully that was helpful. I'm just going to leave you with some tool tips and resources. So we have Kaggle, Data Camp, and Dataversity, our online courses or online course platforms that you could benefit from. KD Nuggets and Towards Data Science are really, really good blogs that I recommend. These are some tools that we use as data scientists, and you can feel free to follow some of the biggest data scientists or influencers, big data influencers on LinkedIn. So I just want to thank you, Trevor. I don't know if you want to say anything quickly before we move into questions and the question session.
Yeah, I want to say thanks for having us as well. I hope it was instructive and informative, and I'm looking forward to the questions. And I think you can reach out to Nigel or myself with any questions you have, even after the end of the session.
Well, first of all, thank you, Trevor, and thank you, Nigel, for this engaging and interactive session. Definitely appreciated. It's been a while since I've seen R, but I'm sure a number of persons who are logged in today may have used that maybe in the last week or so. And I know that a number of the societies and associations that we are a part of have actually just added some courses that do require us to refresh in R and maybe other languages as well. So we do have a couple of questions. And I'm actually going to start off with my question to you, Nigel, and that is, why are data scientists coming after our jobs? It's been one of the topics that have come up all week long, in some degree or the other, as it relates to the fact that data science is now the new in-demand job, and the fact that data scientists are replacing actuaries. So I just kind of actually want to get your view or your opinion on that statement as it relates to data scientists replacing actuaries.
Yeah, so I mean it's a very loaded question, right? So you invited me on your floor to answer. I mean we could probably talk all evening about it, but what I would say is that, I mean, clearly there are some tools and some approaches I think that would be helpful, in my opinion, to what actuaries do. But I would not say that I am going after anyone's job. I think more the employers and the people who are trying to solve hard problems are trying to look for those skills and those techniques, wherever they may come from, that may solve the problems that we need to solve best. So I think that's all I could say, on that succinctly. But what I would say is that, data scientists, people feel like you have to be this unicorn type data scientist, but I don't think you have to be a data scientist to practice data science, in my opinion. And there are tools that you can learn that are well within reach.
So truthfully, Nigel, I think that we are very much so of the same opinion. And we do see that the two professions can merge and can work together quite seamlessly. Actuaries can also be data scientists, and data scientists can also be actuaries. So that was just to open up the Q&A. Don't worry about it. We really do appreciate you and your profession. So I'm just going to go over to the questions here now. We have one from Dane. He wants to know, did you predict the recent results of the THA elections?
Oh my gosh, that's a good that's a good question. Wow, I didn't think you would. I mean, that's not data science and banking, right? But I guess I have to answer the question. All right, so yeah, so I would have been involved in a firm that would have done a public opinion poll, and we did poll THA. It was actually, I guess, unfortunate. Not one of the first poll that the firm would have published that the final results came with outside of the margin of error, right? Of the final poll. So for the first time ever. So I guess if you use a 95% confidence interval, 1 out of every 20 times it's supposed to fall outside. And I guess this was the 1 out of 20 that happened for the Tobago House of Assembly election 2021.
Okay. Thank you for that. We have a question from Brandon. What regulations do you think the Caribbean should be considering around data and data science? Do you think that GDPR style will protect stakeholders or inhibit growth? I think this is a question for Trevor, maybe?
Yeah, great.
All right, privacy. So first, the regulations would obviously be privacy regulations, right? So, and we are seeing those being rolled out across the Caribbean, right? So Barbados, I think, has gazetted theirs. I think for sure Cayman has theirs in place, etc. And you have to strike a balance. And I don't think of it as necessarily inhibiting, but it is one of the guardrails you need to walk inside of if you are going to ultimately bring value to your clients. So what I would say is we kind of take the position that the data isn't ours, it belongs to our clients and we use it. We are transparent, or as transparent as possible with the way it's used, and you stay inside the regulation. I think, especially in the Caribbean, there's a lot of opportunity there to use data and to use data effectively in banking and otherwise, because it's still kind of a nascent practice, I think, in the region. So I don't think it inhibits us too much because of the opportunity that's there, but obviously it's important because your clients come first, right?
I appreciate that response. And we have another question here. Can you explain your thoughts on whether the Caribbean is ready for the use of data science in the banking sector?
It's more than ready. I don't even know if that question was for me, but the thing is, and I think what the Bill Gates quote is what comes to mind, right? And we are very cognizant that we don't only compete with a bank across the road, right? I think what's happened is that clients have come to expect, especially when you talk digital, certain capabilities. And if you are unable to provide them as a bank or as anything else, you're going to be left behind and be irrelevant. So I think that it's right because of the expectations, because people know how, and I think expectations are important. And going back to the first question, whereas 20 years ago, people may have been more apprehensive about the way their data would be used, now people are a little bit more comfortable with that trade-off because they're accustomed to getting value, right, from your Facebooks, et cetera, from that. And so I think the Caribbean is primed actually for the intelligent use of data science and in banking. And one final thing, again, we mentioned a bank being able to use data to extend credit to people who were previously ineligible. And I think there might be a tremendous opportunity there as well, right? So I think it's perfect. But the Caribbean is perfectly poised for the banking industry to take advantage of using data science.
Yeah, I could definitely agree with you there, Trevor. And I think that that goes beyond the banking sector, to be honest. The use of data science can be applied in so many areas and so many industries. And some of the areas that Nigel would have mentioned when he first started speaking as well, political science, retail, etc. So definitely banking as one of the big data producers in the industries that we have within the region. So now the next question, well, this one is a combination of a question / maybe a pet peeve. So let's talk adoption. Was it difficult to shift to move to a more insight-driven structure for banking? I'm having a task, having management to see the world beyond Excel. Imagine the disruption of data-driven approach to insurance. The example given was root insurance in the US. So this can be a bit of both of you.
I think I'll let Nigel. I'll start and I'll let Nigel.
Yeah, Trevor. I think this is for you. You go for it.
So the way we kind of approach that, I think we took the step to make people receptive and comfortable. So we talk internally, we talk about innovation as making the future visible, and we did a lot to make the future tangible for people. So we worked with stakeholders, we partnered with UE to work with different areas across the bank. We built a community. So what I would say is that it is about kind of changing the culture and the perception so that it doesn't seem like something that's far out there. And what comes along with that is maybe not educating, but kind of making people aware that this is the status quo at the moment, right? Like data science is almost table stakes, no matter what industry you're in. What I'd say is to kind of get them comfortable, but also use that as a carrot, but also kind of make your stakeholders aware of what they're leaving on the table and the fact that other people are going to come and eat their lunch if they don't act on it, right? So I'll turn it over to Nigel.
Yeah, Trevor. I like that last point that you made. Back when I ran an analytics company, and I was trying to do training and trying to do this kind of big data revolution in various companies. It was difficult. And I eventually ran over to Trevor and said, Trevor, you know what? I want to work with one firm that is committed to using big data and committed to using data science, and the rest is history, right? So I would say two things. One is that the organization that Trevor and I work for, in my opinion, is one of the most forward thinking in terms of use of big data and being enterprising and willing to fail fast and recover. But also, just like we saw in COVID, when people always wondered, can work from home really work? Would productivity, decline? The fact is, when we had to, right? And right now, using big data, it's existential, right? So I don't think the question is banking ready, right? Some are more ready than others, but one way or another, it's something that we have to do.
Thank you both for that. I definitely agree with your sentiments there. And Trevor, to your point, culture is a very big part of the solution. You have to start by changing the culture and the mindset in order for things to come natural to people and the acceptance of these changes as well. They always say that change is always hard to swallow, but it's inevitable. So the next question we have is, how do you allow for words that have the same spelling but different meaning? This is for you, Nigel. I think it's about the code that you showed with the description.
Good question, right? So what I would say just very briefly is that data is messy, right? And the way I would think about it is the model doesn't rely on so it's two things I would say. One, the model would not rely on something more than it empirically than the empirical signal, right? So for example, if you have one word and sometimes it means X and sometimes it means Y, and X may increase the claim, but Y may decrease the claim, eventually it's just going to say, okay, well, that word has no predictive value or has little predictive value. It will downweight, or it will weight that word less than a word where you see the signal and response, the relationship be a lot clearer. That's one. But secondly, context is very important. So if you actually have a pretty good model, just like we as human beings know what's the meaning of the word, even though if the word may have two meanings, just as we human beings can learn, well, oh, when we hear the word in this context, it means X. But if we hear the word in that context, it means Y. If we have a good machine learning model, it can do the same thing. Hopefully that helps rather than confuse you.
I think so, but it also, I think, partially answers the next question, or maybe completely. The question would depend on how the keywords appear in the data. Their importance might be lost. If spine and back are treated as completely different, the model might miss their significance. How much is human input needed to make sure that the final model makes sense? So I think you kind of...
Great. That's a really good question. That's a really good question. So, I mean, data science is just as much a science as it is an art. And some data scientists will say, you know what, I'm not going to go in and put my hands in it too much. I'm just going to let the computer figure it out in a supervised learning way. But some people say, you know what, I know more than the model could know. So, if I want to put spine and back together and make one column or one feature, that's another way to go. It's never going to be any one extreme. You're probably going to always try to find a balance, but the balance both has to do with, as Trevor said, right sizing. When you right size a problem, right? So how much time do you have, and what's the value of it, right? You're not going to take, an atomic bomb to try to kill a fly, right? So you got to look at that, but also you have to know the amount of data, right? So if you only have 5,000 observations, then going in and making those kinds of human created feature engineering type things may be more important than if you have millions of observations where maybe spine and back are different in some sense. So yeah.
Appreciate that. There are a few more questions, but unfortunately we have run out of time and we do have to step into our next session. But there was a comment that was made by Dion that I just wanted to read out for you. I think Dion says, I think because we can't see big data being used in day-to-day life, we think it's only being used in certain sectors, but a lot goes in behind the scenes in spaces the average person wouldn't realize. I think that definitely is a good way to close the session for today. One of the comments that Monet Renata is here making is that down to the colors used in marketing. Furthermore, the swiping action Facebook chose, insert the social dilemma. So we can see that big data is being used in so many areas that we might not always necessarily see what's happening, but it is there. So I want to thank you both for coming and spending some time with us today. Is definitely appreciated. I know that the actuaries and other professionals on the line today have definitely learned something new. We've definitely expanded, and maybe one or two of us maybe now Googling, okay, how can I transition into data science? So thank you so very much, Trevor, and thank you, Nigel. And to our participants, you can now head over to the last session for the day, disruptions in the banking system, an actuarial perspective. And I will see you guys in the next session. Thank you again and have a good evening.
Thank you. Take care.